Okay, a continuation from last lesson. This is page 50 of your complex numbers booklet. Example 5. Use De Moivre's theorem to solve z to the power of 5 equals -1. And by grouping the roots in complex conjugate pairs, show that z to the power of 5 plus 1 equals this expression here. Okay, let's start by letting z equal r cis theta. That means that z to the power of 5 is equal to r to the power of 5 cis 5 theta, which is r to the power of 5 cos 5 theta plus I sine 5 theta. Okay, now that's using De Moivre's theorem there. If z equals r cis theta, which is r cos theta plus I sine theta, so I can write that there, which is r cos theta plus I sine theta. There's no need to write that all out. Then z to the power of 5 is r to the power of 5 cis 5 theta, which is, of course, this expanded version here. So that's using De Moivre's theorem there. Now remember, when we use this, we come up with an expression for z to the power of 5 here, but we also need to come up with an expression for -1. Now, we want to write -1 as a complex number as well, but however in mod arg form. So -1 would be 1 cos pi plus I sine pi. Now the reason for this, I'll just draw it over here. Now on the complex number plane, we've got 1 is here, but -1 would be here, and the angle, the argument to get to -1 is pi. Okay, also we can also look at the sine and cosine curves as well. We know that cosine curve is like that, and cos of pi, look at the cosine curve, cos of pi is -1, and we also know that with the sine curve, okay, there's your 2 pi, and here's pi, sine of pi is 0. So therefore 1 times, now cos of pi is -1, so 1 times -1 is -1, and 1 times I sine pi, now sine pi is 0, that's just 1 times 0 is 0. So -1 does equal 1 cos pi plus I sine pi. Okay, now equating these two expressions, because we know that z to the power of 5 equals -1, so therefore equating these, we can say, well, therefore r to the power of 5 here is equal to 1, so therefore r equals +1, as r, your modulus, has to be greater than 0. Okay, and we also know that 5 theta equals pi, remember, plus 2k pi, where k equals 0, plus or minus 1, plus or minus 2, etc., an integer. And so therefore we can say that theta, here we know that 5 theta is this, therefore theta is pi on 5 plus 2k pi on 5. Okay, now when k is 0, we get that theta is just pi on 5 plus 0. So therefore, our first complex, our first root, z1, is 1 cis pi on 5. Okay, because remember, where have we got it? We've got that z, your roots are r cis theta, so we know that r is 1, and we've got cis theta. So when k is 0, when this is 0 here, we've got 1 cis pi on 5. Okay, when k equals 1, we get that theta is pi on 5 plus 2 pi on 5, which is 3 pi on 5, and so therefore z2, our second root, is 1 cis 3 pi on 5. Okay, when k is -1, we get that theta is pi on 5 minus 2 pi on 5, which is -pi on 5, Now this is fine. Remember, your arguments, your principal argument needs to lie between negative pi, principal argument goes from 0 to pi or 0 to negative pi, okay? So that's what your principal argument has to lie between, and negative pi on 5 would be somewhere here. So therefore your third root is 1 cis negative pi on 5. Now, when k is positive 2, we get that theta is pi on 5 plus, now if k is 2, we get 4 pi on 5, which gives us 5 pi on 5, which is just pi, and so therefore your fourth root, z sub 4, is 1 cis pi. And when k is negative 2, we get that theta is pi on 5 minus 4 pi on 5, which is minus 3 pi on 5. Now that is within the principal argument, and so therefore Z5 is 1 cis minus 3 pi on 5. Now, if you looked at further substitutions, remember we've got 5 roots and they're all different. Remember, our roots should be equally spaced around the circle. We've got 5 roots. The first one is at pi on 5, which is about, well, if you look at this as 5 pi on 5, so about a fifth of the way. So this might be the first one, pi on 5. The second one is 2 pi on, no, it's not, it's 3 pi on 5, which should be about there. And the next one's here at at pi, okay? So we've got pi on 5, then we've got 3 pi on 5. Actually, I'll just put them up here. Okay, this one is pi. It's actually 1 cis pi. This is 1 cis 3 pi on 5. This is 1 cis pi on 5. Notice what's happening. Pi on 5, 3 pi on 5. This is 5 pi on 5. And coming back down here, this is 1 cis minus pi on 5. And here we've got 1 cis minus, sorry, it's actually more like here, not there. 1 cis minus 3 pi on 5. Okay, so we can see that they're all equally spaced around the circle, and the difference between each one is 2 pi on 5. So that all looks fine. So if we substituted, for example, k is 3, you would get pi on 5 plus 6 pi on 5 is 7 pi on 5. Now 7 pi on 5 just happens to be the same as minus 3 pi on 5, so you wouldn't continue around the circle. So therefore we can say, therefore the roots are, z is negative 1, and we've also got cis, 1 cis is the same as cis, plus or minus 3 pi on 5, and cis plus or minus pi. Actually, no, it's not plus or minus pi. Plus or minus 3 pi on 5 and plus or minus pi on 5. Okay. Because coming back up here, 1 cis pi, we know that cis pi up here is the same as negative 1, because it's 1 times cos pi plus I sine pi, so it's negative 1, which is why I've got here that z is negative 1 here for my first root, again because cis pi is negative 1. If these are our roots, now remember we used, our original question was z to the power of 5 equals negative 1. So they're our solutions to this. But remember, if you've got z to the power of 5 equals negative 1, what you're really doing is solving. So therefore, z to the power of 5 plus 1 equals 0 is what we've really just solved up there. Remember, because z to the power of 5 equals negative 1 really is just z to the power of 5 plus 1 equals 0. So what we've done is that we are able now to factorize this. So we've got that z to the power of 5 plus 1 is equal to z plus 1, because remember it's z minus your root, okay? So it's z minus negative 1. And then we've got z minus cis, we'll just do the smaller ones first, pi on 5, times z minus cis, negative pi on 5, times z minus cis 3 pi on 5 times z minus cis negative 3 pi on 5. Okay, so that's that factorised. Z to the power of 5 plus 1 equals those 5, they're your 5 factors, basically. Now, this is the same as z plus 1 times z minus, we're going to open this all up now. Ways you can do this. I'm actually going to expand my brackets, okay? So I've got, multiplying these two brackets, I've got z times z is z squared. Then I've got minus z cis minus pi on 5. Then I've got minus z cis, multiplying these two, pi on 5. Then multiplying these two, I've got plus cis pi on 5 times cis minus pi on 5. And this is multiplied by, sorry, I just can't fit it on the one line, z squared again, so multiplying these two, minus z cis minus 3 pi on 5 minus z cis positive 3 pi on 5, and then plus cis 3 pi on 5 times cis minus 3 pi on 5. Now, one thing we need to note, when you multiply numbers, for example, cis pi on 5 times cis minus pi on 5, remember you multiply the moduli, but then you add the arguments. So here, where we're going cis pi on 5 times cis minus pi on 5, I probably should have written this in first, but this is just the same as adding pi on 5 plus minus pi on 5. Here I can just write cis 0, and same for this one here, just to write cis 0. So that would have been quicker for me to do that. So I'll just do that on the next line. So I've got z plus 1, and what I'm going to do also, so I'm going to write cis 0 here and cis 0 there, but as I do that as well, I'm going to expand these as well. So I've got z squared minus z, I'm going to expand this, and I've got z cos minus pi on 5, brackets here, just got to be careful, plus z sine minus pi on 5, so I've just expanded that first one. Be really careful here, minus z cos pi on 5, I'll just put a bracket here, plus z sine pi on 5, or I sine actually. So just putting an I sine here and an I sine there. Okay, I sine pi on 5. Then remember, so I've just expanded that, Then we've got plus cis of 0, which will be plus cos 0 plus I sine 0. And then that will be multiplied by z squared minus z, bracket, cos minus 3 pi on 5 plus z, I probably could have put the z out the front, but it doesn't matter, z I sine minus 3 pi on 5. Then we've got minus, expanding this one now, z cos 3 pi on 5 plus I sine 3 pi on 5. And remember, we've got cis 3 pi on 5 times cis minus 3 pi on 5 minus 3 pi on 5 is the same as cis 0, so it'll be plus cos 0 plus I sine 0. Now, let's see what we've got. So we've got z plus 1, just running off screen there, times z squared. Now, we've got the cos of minus pi on 5, that lies in quadrant 4. So minus pi on 5, just looking back at this diagram up here, minus pi on 5 lies in quadrant 4, and cos happens to be positive in quadrant 4. So this is the same as z cos pi on 5. So we've got z squared minus z cos pi on 5. And sine in quadrant 4 is negative, okay? So I'll put the negative in front of here. So I've got minus. So I've just got to be very careful here because I've got minus that and minus that. This is a minus here in front, which gives me plus z I sine pi on 5. Okay, so what I said was this is quadrant 4, so that's the same as putting a minus there. So you've got minus minus makes this positive, okay? Then we've got minus, we've got z cos pi on 5, which would just stay the same. And we've got minus, now this is positive, so we've just got minus that, minus z I sine pi on 5. Then we've got plus cos of 0. Now we know that cos of 0 is 1 and sine of 0 is 0. So we've got plus 1 and times. So we've just done all of this, and this all happens to be, sorry, I need to do my brackets properly. This is just a big square bracket around the outside, and so is this as well, okay? So this is just, basically, it's just the expansion of this. Yep, I've just done the expansion of those two only, and I've ended up with that. Now, expanding this row down here, I've got z squared minus. Now, we know that cos of minus 3 pi on 5 is positive, so we've got z minus cos 3 pi on 5. And we know that sine of minus 3 pi on 5 is the same as minus z I sine 3 pi on 5. So minus minus gives me a plus z I sine 3 pi on 5. Then we've got minus, that will stay the same, minus z cos 3 pi on 5. And just expanding here, minus z I sine 3 pi on 5. And we know that cos of 0 is 1 and sine of 0 is 0. So therefore, collecting like terms, we've got z plus 1 times z squared, and we've got 2 lots of this, so minus 2 lots of z cos pi on 5. We know that z I sine pi on 5 cancels with minus z I sine pi on 5. They cancel. We've got plus 1. And on down here, we've got z squared. We've got 2 of these. So we've got minus 2z cos 3 pi on 5. The plus z I sine 3 pi on 5 cancels with the minus z I 3 pi on 5. And we've got plus 1. Now, I would also be writing, note that cos of negative theta equals cos of theta. I'd be putting that up here. And that sine of negative theta equals minus sine theta. Okay, now we know that these minus pi on 5 equals cos pi on 5. They're both, sorry, this is quadrant 4, and cos minus pi on 5 equals cos pi on 5. We know that this is quadrant 4 as well. Sine minus pi on 5 equals minus sine pi on 5. Now you may say, well, so these two are obviously quadrant 4. But then you might say, well, wait a sec, this cos minus pi on 3 is not quadrant 4, it's quadrant 3. And it actually is. And cos 3 pi on 5 is actually quadrant 2. Okay? Now, if I just sketch that, 3 and pi on 5 is here. And minus 3 pi on 5 is there. Okay? Now, if you actually do on your calculator the cos of 3 pi on 5, you should get a negative answer, okay, because cos is negative in quadrant 2. See, this is actually quadrant 2, all right? and minus 3, and if you actually do this on your calculator, cos minus 3 pi and 5, you'll get a negative answer as well. So if you actually put cos 3 pi and 5 into your calculator and cos minus 3 pi and 5 into your calculator, you'll actually get the same answer of approximately negative 0.3. Now, sine of minus 3 pi and 5 is quadrant 3. We know that sine's negative there, okay? But sine of 3 pi and 5 is quadrant 2, and we know that sine's positive there. That's why sine of minus 3 pi and 5 equals minus sine 3 pi and 5, okay? So what you're trying to do here is you're trying to not write this as cos minus 3 pi and 5 and sine minus 3 pi and 5. They've got to be written as positive angles, okay? So